Hey, welcome to a new session for hands-on modeling for this design automation framework. So what we did last time was that we cleaned up the code. So we created new functions for, let's here review them. We created a function for copy references, create new part and change the name, paste references. And then we also did an instantiate power copy function, and which resulted in a much clean code here. And that will also help us to do the next part, which is to create a rib model and then create a automatic instantiation process for ribs in either wing, horizontal tails, or vertical tail. All right, so I'll get started. So currently in this model we have 3 instances, and as you can see, the instances that we have here are firstly the wing, which includes wing geo. This is the references needed for additional wings to wing model to be instantiated upon this wing, which we demonstrated in the first hands-on example. And basically what we need is that we need another geometric set which contains the geometries necessary to create a rib. And this basically takes us back to, let's see here, the discussion regarding most parent and most child. So in this case, most parent is fuselage, and then the wing is a child to the fuselage, and then we're going to create the rib, which will be the child of the wing. So basically what I'm going to do now is that I'm going to delete these parts. And then I will open the wing power copy as such. And then what I'm going to do is that I'm going to create a new geometrical set, which I will name rib geo. And now what I'm going to do is that I'm going to include the type of geometries necessary in order needed in order to create a rib. So I will need the surfaces, I will need the leading edge and the trailing edge, and then also, let's see, what point is that? It's the point here. Actually, I would need the wing start point, which is in this geometrical set. Let's see if I need something else. No, I think that's it. So what I'll do is that I'm going to go inside the generative shape design. And then I will select this join tool, and now I'm just simply going to select the geometries needed. So here I selected both surfaces that I'm going to call wing surf. And now I'm going to also need leading edge at least the leading edge is needed. I don't think I need the trailing edge. So I'll just take this one, and as you see, I'm just using the join definition function to just select this line, leading edge wing. I'm not actually joining anything. I'm just using it in order to have it in this geometrical set in order to copy it later on for my power copy instantiation. And then I need the wing start point. So then I'm going to create a new point, and then I'm going to select coordinates here, and then wing start 0, 0, 0. There we go. And then I will also call it wing start. And that is not a problem because this wing start is in this geometrical set and this wing start is in this geometrical set. So there is no conflicting of names because they are in different geometrical sets. Let's see, do I need something else? No, I think I'm good. I think this is what's needed. So what I'm going to do now is that I'm going to open up the power copy, and I'm going to make sure that this geometrical set also is selected. And then I press OK, and then I save this, and then I close this down, and then I will do a instantiation again. There we go. And I'll just look at the results, and as you can see here, there's a rib geo here for the wing. There is a rib geo for the horizontal tail, and of course there is one for the vertical tail as well. So what I'll do now is that I'll just select these three references like such. I will copy them, and then I will create a new part. And this part I will rename to rib power copy. Let's see. Let's take away the underscore. Rib PC. There we go. And then I'm going to just paste special as result. No link needed for the power copy part, but I think I selected the wrong references. So let me just remove this, and then I go back to here, and then I will copy this again, and then paste special. Let's see. Yeah, this happens sometimes. So what I need to do in order to make this work is that sometimes you cannot be in product and select. So what you need to do is that you need to double click on the actual part. So you're inside the part, and then you select them here, copy. Then you can go back to the product by double clicking on it, going to this one, and then paste special as result. And now we have the references. So I will zoom out, and this is basically what I have. So what I'll do now is I'll start making a very elementary rib. I don't want to overdo it. I don't want to do it too complicated. Simplified geometry in order to be able to test the whole project as many times as possible, as soon as possible. So I'll create a geometrical set, geometry, let's call it. And then I need to change the order because I don't like there we go. And this one is, let's see what we call them in the wing PC. We call them references needed. So let's reuse the same name here, reference as needed. There we go. And let's see here. We have the wing start, we have the actual leading edge for the wing, and then we have the surface. So what I'll do now is that I'll create a point on this line, and then I will choose this point as a starting, and then a ratio on curve like 0.2 or something, and then we have the point here. I'll create 2 parameters. And then I will call the first one position wing, and right click power properties, and then this one thickness wing, let's say, and this is 0.3, and maybe this is, I don't know, 0.1. All right, I'll create a new point on this line, and then from this point, and then edit formula, and I'll take the thick wing. There we go. And then I go inside this value, edit formula, and then I choose the position for wing. There we go. And then if I make this a little bit smaller, let's see, 0.05. There we go. All right. Okay, so I need some more geometries, and I'm going to use some new functions. There's a function which is called boundary. If I take this boundary function and I click on wing surf, and then I take a limiter, which is, right now if I take the boundaries, it will give me the splines that are open for this surface. And I don't want both of them, so I want to be able to separate them. So the limiter, if I select this point, then I will get this spline first here, and then I will create a new point on this leading edge on 1, and then I will create a new boundary with the limiter on this point instead, so then I will get this boundary. There we go. And then I will create ratio 0 on this boundary, and then ratio 0 on this boundary, and then I will get an endpoint on both the root chord and the tip chord. I can connect them with a line like such. All right, so I need some planes for creating the actual ribs. So what I'll do is that, depending on the points I have here, this one and this one and this one, I create a new plane which is positioned here. Right, so now we'll have to take this plane and then rotate it in order to get the right direction for the ribs. And for that we need to use the plane function angle normal to plane, and then I'll use this plane as I already created, and then rotation axis is actually this line, and then 90 degrees, and then OK. And then I will take this plane and place it on these 2 positions here, and also here. There we go. Yeah, that looks to be right. All right, so I've already done some modeling, and before I continue, now is a good time to save. I should have actually saved a while back, but let's do it now. And then let me create a power copy. Well, I select this geometry, the parameter, the relations, and what I see is that the input that is needed in order to instantiate the rib power copy is the leading edge line, the wing start, and the wing surf, which looks to be correct with the ones that I have listed here. Then I press OK and then save again. All right, so what will be interesting now is to see how this all works with the automation routine that we already have. So what I will do now is that I will just go to my code here, and then I will select these parts for the horizontal tail and vertical tail, and I will just let's see here, view, we should have some kind of a right click, debug. There we go. So then I can just comment them out. Wasn't there maybe edit? Yeah. Just try to place it right. All right, and then comment them. So now this will not be read. And basically I will just copy this whole code because I have a new reference now. My new reference will not be the fuselage, my new reference will be the actual wing. And when the wing is, let's do like this, we'll just press, we'll stop the code here. So I run the code until this point, like that. So now we have instantiated the wing. And it's called wing 1, 2, 3, and then we have this rib geo with the 3 references. All right, so what we want to do now is that we want to do this whole process of copying the references that we need and then doing the whole, let's see, where were we? Here, creating copy the references and then the part and the name and the pasting and the instantiating and so on. So, in order to do the copy of the references, what we need is essentially the hybrid bodies of the part where the references are located, and then also the name of those references. And in this function here, when we create a new part, let's go and see what the definition of that part is. It is actually a dot part, as you can see here. So essentially what I should be able to do is to, sorry for that, this line I do not need, and here, if instead of reference dot part, I can simply take this one like that. And the thing here is that I will not instantiate the wing power copy here anymore. Instead, what I'm going to instantiate is actually the, let's see here, the rib power copy. Copy that name, put it here. And the references which are going to be copied is not the wing geo, it is the rib geo. So I will modify that as well. And the name of the part which is created, let's not call it wing 123, let's call it rib 123. There is still no order and structure when it comes to naming, as you can see, but that is something which we will take during the next hands-on sessions. All right, I think that is it. So if I run this code, then we should have a rib instantiated in this product. Let's just run it and see what happens. Well, it did not work. And the reason for why it didn't work is because we missed a critical step, and that the reason is that we didn't change the name of this power copy. It should be named PC. So we'll save this and then go back to our code. You see here the name is defined as PC. So it goes into the rib PC, but the name should also be correct. So let's see. So now it has instantiated this part based on the references defined here. And as you can see, it looks quite good. All right, so I took the courtesy to pause the recording for a bit, and I cleaned up the code just a tad. So now I have two definitions for the power copy. One is PC1 and one is PC2, and they point to different parts. And then also I changed the name of this hybrid bodies. It was hybrid bodies 1 before, but now I changed it to hybrid bodies 2, so that it's not mixed with the hybrid bodies 1, which is defined for the fuselage. So now when we have this code, I think it's about time to remove the comments for what we commented out before. So now we're going to test this rib instantiation. This is still on a testing phase, so nothing is complete right now. We just want to test it. So for the horizontal tail, it will be instantiated on the part that has been already created here. Hybrid bodies 2 is dependent on the new one part, which is created here when we created our part. So yeah, let's run this and see what happens. Yeah, so I made a small mistake. I cannot have the same name for different parts. So I'll just stop this and then I'll remove these parts again. This is the problem with copy paste. So let's call this rib 1, let's call this one rib 2, and then let's call this one rib 3. Let's try it again. Not sure exactly what happened there, but let's try it again. There we go. So what I wanted to verify is that the rib geometry that we have created is actually instantiated in the correct way for the different different wings, especially for this vertical tail, because it has a completely another direction in space than compared to the wings and the horizontal tail. But as we can see here, it is perfectly aligned. And just to be sure, let's just change the position of the wing here. Actually, when I see it now, it shouldn't be position wing, it should be position rib, of course. So we'll modify that later. Yeah, this works, so it's a good test. And now I'll just remove these parts again. There we go. And then I will open up the rib power copy. Yeah, this sometimes happens. When you do power copy instantiations, sometimes the power copy factory is not closed in the code when you're debugging. It happens. So what you should do is that when you get this message, you click no, make sure you close this down, you save your product, you close down CATIA, and then you need to start up CATIA again, basically. And let's see. So what I'll do now is that when I get my session up and going, I will start by changing the name of the parameter so that it's called rib position and not wing position, as it was wrongly called. And then after that I will start immediately with creating my rib geometries. So here, this one should be position rib, and this one should be thickness rib. There we go. And now is the time for creating the actual rib geometry. So that's the fun part. So what I want to do is that I want to get a completely closed surface. I'll do a fill on this boundary, and then I will do yet another fill on this boundary, and then I will join these surfaces like such, and then I will create a new body, which I will create. I will go to a new workbench, part design, and here I will do a fill, a close surface is called, of this join. Okay, and now if I hide this join, I can see that I have a complete solid here. And now what I'll do is that I'll use the split tool, which is included here, and I will split this into operations. There we go. And now if I select this body, I have everything I need in order to do the instantiations. I can actually hide this one, and these can be hidden as well. And now if I change the position of the rib, you can see it's modified and 0.2, and the thickness is also corresponding. So this works. I save it, and then I will open up my aircraft product and go to my test code where I am instantiating the wings, horizontal tails, and the vertical tail, and I'm also instantiating one rib per jump. Alright, so we have the ribs instantiated for each wing, and if we will just change the position, and we can see that it's also moved accordingly, which is great. Yeah, so this works, and for the next session what we need to do is to make this all a little bit more structured. So what we need to do is to do this process. Depending on the number of ribs, we need to be able to instantiate and then also change the position of the rib. So that's next. Okay, so let's do exactly that. Let's do a instantiation of ribs so that we can instantiate a number of ribs in these various wing sections. So what we have currently is that we are first instantiating some kind of a wing geometry, and then we instantiate the ribs. So basically what we need to do here is that we need to create a loop where we increase the number of ribs that are created. So let's say I create a loop here from I is equal to 1 to 5, and then I need to have a next here. So this defines my loop, and here it's important that I change the name of the rib to something like this. So we get let's say rib wing, and then it starts, the first one will get name number 1, and then 2, 3, 4, and 5 in this case. Yeah, and all of them will, the references that are going to, the references that they're going to have is taken from the new part, which is the wing that we had instantiated previously. This line doesn't have to be inside the loop, so that we will take outside. And let's see here, we copy the references. That is also something which we don't need to do each time in the loop. That is just unnecessary, because we only need to copy the references from this wing part once and not every time during the loop. However, we need to create a part, we need to change the name of the part, which we do in this function as well. We paste the references, update, and then we go inside the references, and then we do some type of here we do the instantiation process. So what we need to put here in order for this to actually make sense is that we need to change the position of the ribs. So we need to put this line here as well, modify instance parameter. So in this case we are in the part, and when we are in the part we can define a set parameters 2, let's call it, and this will be from the part parameters, and here we should be able to go inside a specific parameter and then modify its value. Let's see, here are the parameters that we have, position rib and thickness rib. I will just copy the name of this one, and then let's see, basically I need to go into parameters 2.item, and here the name is position rib, and then the value of this parameter will be modified to something. What is something? I will take a formula here, 0.1 times I, or maybe 0.15, really doesn't matter. So I will just do a very simple automation routine so that when it is instantiated, I also go inside the parameters and then change the value of the parameters. That's the idea. So let's test it out and see what happens. And yeah, basically we have all these ribs, rib wing 1, 2, 3, 4, and 5. However, it's red here, and the reason for that is that we didn't do any update. So if we update everything as I did now manually, then everything is put in place correctly. Now there are a lot of references which we need to hide in order to actually view the ribs, but yeah, here they are. So this seems to be working good. So finally, the only thing that is left to do is to add this to the other parts as well. So let's see. I also need to put a new part dot update here. Let's see, exactly. So now it will update the part so that it's not reddish when instantiated, and change the value. All right. So I will just let me just copy the whole here, and then I will replace it with this one and replace it with this one. This one I will call rib horizontal tail. Let's say that the first one is 7, this one is maybe 3, and the last one is 5, and this one will be rib vertical tail. Okay, so for those of you who have paid attention regarding how to make the code more efficient, as you can see now, I'm again building up a lot of repetitive code. So this section, and this section is very, very similar, repetitive. So basically what I should do here, I mean, the same thing goes for this section, to be honest. So what I really should do is that I should create new functions again, so that I can make the code even more efficient. But let's test this first and see what happens. All right, so it's building up, and now we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Where is the 7th? Oh, the 7th became a little bit too, yeah, so the logic wasn't that great. So hopefully you can write a better logic than I could. Obviously it shouldn't be above value 100% for the ratio, otherwise it's not shown. And then we have a horizontal tail, 3 ribs as we have written, and vertical tail ribs is 5. All right, so you could imagine that if I would, this is the back end programming, okay? So what was important for me is that you get a feeling of how to work with these power copies, how to plan these power copies, how to test these power copies, and also give you an idea regarding what you can do in the VB editor in Excel, and how much this is a more appropriate tool to use than being in reaction function in CATIA, and how much you can do by making your code more efficient. So my idea has always been to create this complete design automation aircraft configurator. This is actually an old project that I had done previously myself. So I know that it's not so hard to do it, but it takes time. So at this point, I'm not very sure if I will go ahead and complete this task. It really depends on how much time I have. From a pedagogical point and perspective, I think the knowledge that I wanted to convey is already is done. So it was very important for me to show you how the process of writing the code and balancing it with the modeling, how that should be done. And I think that I have shown that. That is the most important thing to do. There is another side to this, and that is a front end coding, which is to create your own user interface and so on. That is also something that you can do with the VB editor, and honestly, what I can say there is that is something entirely up to how much time you have, how much you want to dive into the projects. But I don't think that I will manage to take my time to do that. Hopefully, I'll have that time, but as it is right now, I'm really not sure. In either case, let me know what you think about this during the next survey, and if you really think that there is an idea and a reason for why I should continue and take this all the way to a complete aircraft, I'm all ears. Just let me know, give me good reasons, maybe I'll do it then. And otherwise, I think that this has been a learning experience for you. And yeah, thank you for watching. Bye.